So for this first one, they give you a graph of a function f, which we're probably getting used to these very exotic and messed up graphs here. And then they don't give you a function for g of x or a graph, they just give you these points in a table for g of x. But you have two separate functions. This is f and this is g. So here's what they tell us. The graph of the function f is shown in the xy plane above. That just means it's on the xy axis. F has a discontinuity due to a vertical asymptote at 6. So they didn't dot this in, but that would be a vertical asymptote here on both sides. And then weirdly, they stuck a floating point on the asymptote just for extra fun, so that's weird. Let g be a function that is continuous, so g doesn't have any holes or breaks or problems, and is increasing for all values of x. G of x is given in the table. So that's everything they gave us, and then here are the questions they're going to ask us. Using all the information that they gave us, estimate limit as x goes to 0, f of x minus g of x. Well, we would just do those two limits and subtract them. So limit as x goes to 0 of f of x minus limit as x goes to 0 of g of x. And all we have to do is find those values here. So let's look at f of x. What is the limit as x goes to 0? So just by typing in the chat, just everybody look at this graph. We want the limit as x goes to 0. So what is that value going to be? Good. Nice job, guys. 2. Both sides are headed to 2, so that part is 2. Minus, and now we're going to do the same thing for g of x, except we don't have a graph to look at. But notice, and we did an example like this in class, do you see how all of these x values are headed towards 0? They're getting closer and closer and zooming in on 0 from each side. So we just need to look at the g of x values. What are they both getting closer and closer to as x goes to 0? Like, what are these both approaching on each side? Yeah, good. Also 2. So 2 minus 2, 0. Cool. So that is letter A. All right, letter B. For each of these values, 1, 2, 4, and 6, find the limit for f of x or explain why it does not exist. Okay, so this is basically a 4-part problem. We're going to do limit as x approaches 1, limit as x approaches 2, we're going to do 4, and we're going to do 6. And I know you can't see all of them. I'm going to move the paper up. But I just kind of set that up. They want us to do all 4 of those. So let's look at the graph. Limit as x approaches 1. What do you guys think? What's going on at 1? Do we get an answer, or do we get does not exist, or what's the story here at 1? Good. Does not exist. And it is because the limits from the left and the right do not agree with each other. And they said we had to put a reason why if it was does not exist. So I'm going to say because limit as x approaches 1 from the left doesn't equal limit as x approaches 1 from the right. So those two are not equal to each other. All right, so then let's look at 2. Here's 2. I know there's a hole there, but it doesn't matter. Both sides are approaching 1. So we get an answer for that one, and that's cool because we don't have to explain anything. That's just our answer. All right, then looking at 4, here's 4. Both sides are approaching -1. And so again, that's awesome because I don't have to put an explanation. My answer is just -1. And then 6, we have an asymptote there. I realize there's a point somewhere else, but that point is just hanging out there. Both sides are going to positive infinity, so this is going to be does not exist. So I'm going to say because limit as x approaches 6 from the left is infinity, and limit as x approaches 6 from the right is infinity. What we're saying is both sides of the graph are going upwards. It's increasing without bound. And you cannot get away with just writing because there's an asymptote in words like that. Like they're gonna say, where does it say it on here? They're gonna say use correct limit notation in your answers. So if you were wondering why is she being so picky about this on our quiz? It's because that's what they're gonna do to you on the AP exam, and that's what I'm trying to get you ready for. So I'm not trying to be mean, but that's how you're gonna have to write it on there. All right, and then letter C, is the function continuous at -3? So it's like a yes or a no, and then justify your answer. All right, so let's see what's going on at -3. Do we think that -3 is a yes or a no? Do you guys think yes or no for x equals -3? Is the graph continuous there? So no, we have an issue at -3. Let's go through our rules. Is there a point? Yes, we have a point. And is there a limit? Yes, both sides are going to the same place. But the point and the limit don't meet up with each other. They are not equal. So our answer is no. The limit as x goes to -3 of the function doesn't equal f of -3. All right, cool. You guys survived your first free response AP problem. We're just going to do one more, and then we'll do a break here. All right, so this second one, let f be a function given by, here, let me write that a whole lot bigger here because it's just really small. There we go, that's better. A and B are constants. That just means those are numbers. The graph of f has a horizontal asymptote at y equals 3. So the graph is going to level off at 3 on both sides. And we have a removable discontinuity at x equals 2. So removable means that there is a hole there. So we have a hole at x equals 2. So it says, letter A, show that A is 6 and B is -13. So they are telling you what the answers are. They just want you to show it. All right, so first let's look at A. They're telling us A is 6. We just have to kind of prove why. And it's going to come from this piece of information. If we have a horizontal asymptote at 3, that means the limit as x goes to infinity of this function is 3. We've got to level off at 3 on both sides. And so since these powers are the same, we're going to use the coefficients. A over 2 would have to equal 3 for us to level off there. And so A equals 6. So again, if we want to level off at 3, look, comparing your powers here, they're the same. So we would use the coefficients A over 2. And if that has to equal 3, then A has to equal 6. And then looking at B, that's going to come from this other piece of information. We know that we have a hole at x equals 2. So the limit as x goes to 2 of this function is going to go to 0 over 0. And the reason I drew an arrow instead of an equal sign, on the AP exam, they don't like when you write equals 0 over 0 because technically that's not a number. So I just put an arrow instead. But that's going to have to go to 0 over 0. And so f of x equals, and we're going to need to factor all of this apart. So let's look at the denominator first because we actually have all of that information. If you take a 2 out of that, you'll be left with x squared minus 4. And then that is going to split x plus 2, x minus 2. And then we're going to need to split the numerator. We're kind of missing a lot of information here, but if we have a whole at 2, I know one of the factors has to be x minus 2. If we have a whole at 2, this is going to have to cancel out. Also, we said a was, what did we say a was? A was 6. Is that what I have there? A was 6. So this is going to have to be 6x. Sorry, my brain kind of shut off for a second. You said A was 6, right? And then in order to end up with a positive 2 here at the end, I'm going to need this to be a negative 1. Negative 1 times negative 2 would give me a positive 2. So if we multiply that back together, let's see what we get. That would be 6x squared. The outsides would give us negative 12x. The insides would give us negative 1x. So minus 13x and then plus 2. This I'm just going to copy over. I don't really need that part so much. But I'm getting b was negative 13. Is that what we were trying to prove it was? Yes. Show that b equals negative 13. So b equals negative 13. So since there was a whole at 2, I knew that this had to cancel. And then I multiplied it all back together and showed that that value had to be negative 13. All right, so let's see what b is asking us for. To make the function continuous at 2, f of 2 should be defined as what value? Okay, well that means we need to do the limit as x goes to 2. And I'm not going to rewrite this because I have it all right there. I really just need this part. We've already gotten this to cancel out. So if we plug into, let's see what we get. That would be 12 minus 1 would be 11. And then down here, 2 plus 2 would be 4. And then double that is 8. So f of 2 should be 11/8. And we had already done like the hard work for that part of the problem already. We had already gotten this canceled out. I just need to basically just plug 2 into that part of the function. All right, and then the last one, at what value of x does f have a discontinuity due to a vertical asymptote? Give a reason for your answer. So they're just saying, where is the vertical asymptote? Well, again, let's look back here because we already did all of this work. This is where the hole was. Where is the vertical asymptote going to have to be? What x value is going to give us a vertical asymptote? Yeah, good. Thank you, guys. That's going to have to be negative 2. So x equals negative 2 because, and the reason you guys are saying that is because it makes this 0. So because the denominator is 0, oops, I can spell. But the numerator isn't. So that is where you would have a vertical asymptote.